Hello, I'm Justine Murphy with Vision Systems Design's Focus on Vision. There are a lot of exciting things happening in machine vision and imaging. Let's take a look. Traditionally, the process of loading and unloading vials of vaccines on and off mobile trolleys required several humans, manually loading vials into trays or boxes, stacking them on pallets or in trolleys, and unloading them again later. But now there's a new solution. Two German companies, Goldfuss Engineering, a robotic loading system specialist, and Simon IBV, which focuses on imaging solutions and software, have developed an autonomous system for this loading and unloading process. Each trolley has 9 drawers that hold around 10,000 vials in total. This new solution, called a robot cell, involves robots equipped with high-resolution 3D cameras, as well as an onboard computer loaded with machine vision software and a programmable logic controller that contains key information about the entire process. The developers say their system was originally created to meet the needs of a company working to significantly increase production of a vaccine. Growers in controlled environment agriculture settings, in which plants are grown indoors under ideal conditions, often in a soil-less growing medium, have been exploring machine vision and related technologies to automate monitoring processes, ultimately for successful year-round harvesting. Now, a new system is doing just that. Researchers at Penn State are studying the performance of a machine vision system equipped with an AI-enabled image segmentation model that could continuously track the growth, specifically of bok choy cultivated in a greenhouse. The team's work involves evaluating a recursive image segmentation model they say is ideal for monitoring plants. The approach uses segmentation results from previous sets of images as prompts for segmentation of a current set of images. It overcomes a conventional challenge, detecting individual plants in images that show leaves from neighboring plants overlapping. In a series of experiments, researchers compared segmentation results from their model with 2 versions of the Segment Anything model, or SAM. The performance of both versions of SAM declined once the plant's leaves overlapped. Meanwhile, the recursive segmentation model maintained superior performance. We're all familiar with DashCams mounted in vehicles, recording traffic events in a loop. Now, engineers are using a similar type of camera in manufacturing to monitor production. Like those in a car, industrial dashcams continuously record and overwrite video data. When triggered by a connected sensor, like a distance or laser sensor, or by a PLC signal, the dashcams save a sequence capturing moments before and after an event, depending on the configured mode. This flexibility allows users to record footage for error analysis. Industrial systems often operate seamlessly for days before errors occur randomly. With their storage and trigger functionality, industrial dashcams capture short, meaningful video sequences around the error event without generating unnecessary recordings. The goal is to prevent unplanned downtime, which is expensive, costing the world's 500 largest companies about 11% of their revenue, according to a research done by Siemens. That's it for this edition of Focus on Vision. Be sure to like and share and subscribe to our YouTube channel, follow us on social media, and visit vision-systems.com for the most up-to-date, interesting, and exciting news impacting the machine vision and imaging industry.